So first, I want to orientate you to how this is set up in Azure. GlobalMantix is hosting a dev or test application of no real significance to the business on a virtual machine that you can see here, the Globo Juice Shop. Now, this test application and the instructions to set this environment up are also available in the demo files, along with the exploits ran for each demonstration and detection queries if you want to follow along or level up your security analyst capabilities on your own. This is just a standard Ubuntu VM running the self-contained application to sell some juice, a side business GlobalMantix has been considering. Clearly very tangential and supportive of their main robotics and dark energy ventures. Now, with Azure VMs, they exist within a local VPC subnet, and they have a NIC that's publicly accessible as well, and that is how you set those VMs or services up. But to enable the web application firewall utility, you instead need to place the access to this VM over port 80 behind what is called the application gateway. This one component essentially fulfills a load balancer and external gateway function. But hold on, not all application gateways are created equal. You have to have a medium instance or greater to enable the web application firewall feature on the application gateway as well. Now, there are plenty of other courses on Pluralsight on setting up application gateways in Azure, so you can check those out for a more detailed setup. But once provisioning the web application firewall, you can see the WAF tab on the left here. Set to detection, not prevention, and with the OWASP 3.0 rules enabled. Now in advanced mode, you can select which of the rules are enforced and how, but for now, just leave them all enabled. To access the web app through this front end, simply browse to the IP or the DNS name of the application gateway in the overview. Doing so, you get the shiny new test front end for the GlobalMantix Juice Enterprise. You can accept cookies or practice some self-control and wait, and do all the things you normally would do in a storefront web application. This specific application is a Node.js app, and the front end and back end code is going to look a bit different than the GlobalMantix internal applications that are based on a LAMP stack. So all caught up, let's take a look at the methodology for the execution of cross-site scripting exploit. The first requirement is a page that accepts user input, and the main page here has a search bar that seems to do just that. Even better is that after clicking search, the page returns the search string in the page. Now this can be done a few different ways, so you want to check and see how this was included. And you can hit the F12 button on the PC for the developer tools and use the inspect tool to select the search string results. It appears to have been added directly to the page, and this is promising. So the next step would be to see if this page will parse an HTML tag and embed that tag as HTML in the response. And you can do that with an H1 tag like so. It didn't error out, and when you look again at the element, you will see that it has included the text with the H1 tag parsed as HTML code. So it seems like this input field is ready to process some code for you. Remember, this is reflected, so this is only going to show up within your browser section, and it's not permanently modifying the source code. The next level, and the level that should get caught by an OWASP CRS rule, is the use of the script tag in this classic cross-site scripting test input with the alert function. Though this time when it runs, the results are not displayed, and it didn't really work. This can be for a number of reasons, and the good news for attackers and bad news for you as an analyst that there is more than one way to perform cross-site scripting. The iframe tag can be used here to call a JavaScript and then subsequently call the alert function or whatever function you would like, and once you give that a shot, it does the trick. Depending on the implementation of the authentication mechanisms, a field that accepts executable code in the login page may allow for authentication bypass. If you attempt to use the same script tag for cross-site scripting injection in the mail field on the Juice Shop login, you'll get an error that shows that it may actually be susceptible to this type of attack. Now, most modern frameworks and developer teams are not going to have these sorts of holes, but no one's perfect all the time. And your job as a security analyst is to make sure that you have a window into the data to detect anyone trying to take advantage of human nature. So in Azure, I set up Log Analytics Workspace and set the web application firewall logs to be sent there. This workspace is a pretty powerful and user-friendly enough area to run queries against the logs coming from the WAF. Much like the Apache main bucket, Azure Diagnostics contains the access logs and the WAF detections, but you can filter by the firewall log category with this query here. And in doing so, there are quite a few detections. No reason to chase these down. It's a dev site that's open up to the internet, and it's going to be scanned and have automated exploits ran against it non-stop. And those are many of the detections that you see here, including a familiar SQLI warning that's formatted according to the standard for OWASP rule groups. Using those rule groups, I'm searching for the 941 cross-site scripting rule group and rewarded with a list of detections for cross-site scripting that match up to every which way I just showed you to try and take advantage of this vulnerability. Not only is this a great way to mitigate the risk of vulnerabilities that are detected and either waiting to be patched or can't be patched for some time, but also if you enable this rule in protection mode, many of those attacks wouldn't have even gotten through. But I encourage you to try a few different types of cross-site scripting on multiple different inputs and web pages of your own while having this WAF in detection mode to see what it does and does not catch. If you'll notice, the reflected cross-site scripting that stayed in the client browser was not detected, whereas the attempts to inject the code into the email field were the cause of the alerts found here.